Section 3.1 Mathematical Expressions. In this video we will learn the definition of a mathematical expression and how to translate a phrase into a mathematical expression, how to translate phrases that are sums, differences, products, and quotients, and how to translate phrases that are combinations of mathematical operations. Recall the definition of a variable presented in section 1.6. A variable is a symbol, usually a letter, that stands for a value that may vary. Let's add the definition of a mathematical expression. When we combine numbers and variables in a valid way, using operations such as addition, subtraction, multiplication, division, exponentiation, and other operations and functions as yet unlearned, the resulting combination of mathematical symbols is called a mathematical expression. Thus, 2a x plus 5 and y squared, being formed by a combination of numbers, variables, and mathematical operators, are valid mathematical expressions. A mathematical expression must be well formed. For example, 2 plus division symbol 5x is not a valid expression because there is no term following the plus sign. It is not valid to write plus division with nothing between these operators. Similarly, 2 plus 3 parentheses 2 is not well formed because parentheses are not balanced. Translating words into mathematical expressions. In this section, we turn our attention to translating word phrases into mathematical expressions. We begin with phrases that translate into sums. There is a wide variety of word phrases that translate into sums. Some common examples are given in Table 3.1a. Though the list is far from complete, in like manner, a number of phrases that translate into differences are known in Table 3.1b. Let's look at some examples, some of which translate into expressions involving sums, and some of which translate into expressions involving differences. Example 1. Translate the following phrases into mathematical expressions. A. 12 larger than x. A. 12 larger than x, B. 11 less than y, and C. R decreased by 9. Solution. Here are the translations. 12 larger than x translates to x plus 12. 11 less than y becomes y minus 11. And r decreased by 9 becomes r minus 9. Example 2. Let W represent the width of the rectangle. The length of a rectangle is 4 feet longer than its width. Express the length of the rectangle in terms of its width, W. Solution. We know that the width of the rectangle is W. Because the length of the rectangle is 4 feet longer than the width, we must add 4 to the width to find the length. So the length is equal to 4 more than, which is plus, the width, which is W. Thus the length of the rectangle in terms of its width, W, is 4 plus W. Example 3. A string measures 15 inches and is cut into 2 pieces. Let x represent the length of one of the resulting pieces. Express the length of the second piece in terms of the length of x of the first piece. Solution. The string has original length 15 inches. It is cut into 2 pieces and the first piece has length x. To find the length of the second piece, we must subtract the length of the first piece from the total length. So, the length of the second piece is equal to the total length minus the length of the first piece, or 15 minus x. Thus, the length of the second piece, in terms of the length x of the first piece, is 15 minus x. There is also a wide variety of phrases that translate into products. Some examples are shown in Table 3.2a, though, again, the list is far from complete. In Table 3.2a, we have the product of x and 12 translates to 12x, 4 times b translates to 4b, and twice r translates to 2r. In like manner, a number of phrases translate into quotients, as shown in Table 3.2b. Quotient of x and 12 translates to x divided by 12. 4 divided by b translates to 4 divided by b, 4 over b. And the ratio of 44 to r translates to 44 over r, or 44 divided by r. Let's look at some examples, some of which translate into expressions involving products, and some of which translate into expressions involving quotients. Example 4. Translate the following phrases into mathematical expressions. A. 11 times x becomes 11x. B. The quotient of y and 4 becomes y over 4, or equivalently y divided by 4. And C, twice a translates to 2 A, or the product of 2 and A. Example 5. A plumber has a pipe of unknown length x. He cuts it into 4 equal pieces. Find the length of each piece in terms of the unknown length x. Solution. The total length is unknown and equal to x. The plumber divides it into 4 equal pieces. To find the length of each piece, we must divide the total length by 4. So we have the length of each piece is equal to the total length of x divided by, or division symbol, 4. Thus, the length of each piece in terms of the unknown length x is x divided by 4, or x over 4. Example 6. Mary invests $80 in a savings account paying 2% interest per year. She invests 5 times this amount in a certificate of deposit paying 5% per year. How much does she invest in the certificate of deposit in terms of the amount A in the savings account? Solution. The amount in the savings account is $80. She invests 5 times this amount in a certificate of deposit. So we have the amount in the CD is 5 times the amount in the savings. So 5 times A, or the product of 5 and A. Thus, the amount invested in the certificate of deposit in terms of the amount A in the savings account is the product of 5 and A. Combinations. Some phrases require combinations of the mathematical operations employed in previous examples. Example 7. Let the first number equal x. The second number is 3 more than twice the first number. Express the second number in terms of the first number x. Solution. The first number is x. The second number is 3 more than twice the first number. So we have the second number is equal to 3 more than or plus twice the first number, the product of 2 and x. Therefore, the second number in terms of the first number, x, is 3 plus the product of 2 and x, or 3 plus 2x. Example 8. The length of a rectangle is L. The width is 15 less than 3 times the length. What is the width of the rectangle in terms of the length L? Solution. The length of the rectangle is L. The width is 15 feet less than 3 times the length. So we have width is 3 times the length, or 3L, less than, minus, 15. Therefore, the width in terms of the length is the product of 3 and L minus 15.